All right, so in this tutorial, we're going to be looking at linear regression diagnostics. So we're going to start with the example that we were working on in the last video, which is a linear model for from the MT cars data set using I can't type the MPG modeled against the quarter second time or the quarter mile time in seconds. So MPG modeled with qsec and data equals MT cars. Now this was our original version, and for this discussion, it doesn't really matter that we actually found that we wanted to get rid of the intercept. We could just as easily go back to our second version of this model and do qsec plus 0 because that was our final model since we wanted to eliminate the intercept. But for this discussion, having the perfect model doesn't really matter. We just need a linear model. So this was our first version of that linear model. Now, in terms of the code, at this point, whatever our model is, we could then use our fit to make predictions for our MPGs based on our equation. So what we're going to do is we're going to create a new column in our data frame, which we're going to call predicted. And we're going to use the predict function on our model to take the values that are in our data set and predict the Y values, the MPG values for that regression model. And then we can also, again, output to our data set as a new column the residuals from our model, residuals from the fit. And essentially, these are already calculated, where these functions are basically just extracting the data that's already in the model. And we're just putting it into our MT cars data set. And so from here, we can then go ahead and create some of our diagnostic plots. Now I'm going to use ggplot in order to make my residual plot. So we're going to call up our data set, which now has this information in it. AES, our aesthetics, X is equal to qsec, and Y is going to be the residual column that we just created. Now, anytime you're plotting a residual model, the way that we usually do this in statistics is we plot the residuals against the X variables. If we have more than one X variable, then we will plot the residuals against every X variable in our model. Now, you will sometimes see residual plots plotted against the Y variables and sometimes plotted against the fitted variables. These are perfectly valid ways of looking at your residuals, but that is not the way that they're usually done in statistics. But you will see them done. Sometimes it's a useful way of looking at them without having to plot multiple plots when you have a lot of variables in your model. And so I'm just going to add a title. This is a geom point plot. So it's a scatter plot, but it's going to compare, again, the X variable that the predictions are based on against the residuals that we extracted from our regression model. And when I go ahead and run that, I get something that looks like this. Now, ideally for residual plots, we want the residual plot to look random. We don't want to see any patterns in the data. We would prefer not to have any outliers that are either way off to one side or way above or way below the rest of the data. Random is what we want. If we see patterns, That might indicate there's some nonlinear relationship with our data. And if we see various behaviors like some sort of trumpeting effect where the spread of the data is getting wider as it goes from one side of the graph to the other, that would be a sign of non-constant variance. Those are all violations of our assumptions of our linear model, and that would be an indication that our model is not a good fit for our data. These residuals are very spread out, but they are random, which suggests that even though the correlation is not great, it's not nonlinear, it's not violating our assumptions, generally speaking. Now, there are other ways to get various diagnostic plots for our linear model, and if you can just plot the fit. Now, if you only want to plot one at a time, one graph at a time, then you can just do this which attribute and specify which of the many graphs that you can get out of the graph, out of this plot, out of this model. Just specify which one you want. We're going to look at all of them in a second, but for right now, we're just going to stick with the second one, which equals 2. And if I run that, this is the normal plot, the QQ plot for our residuals. And so that gives us an idea of how normal the residuals are. That is another diagnostic test that we usually want to try to plot, just to see if, because that is an assumption that we are making about our errors, is that they are normally distributed with a mean of 0 and a constant variance. And we can see that, like, some of these, they don't look too bad until you get, there's a couple of them at the end here that really start to deviate from that normal distribution. And so that could potentially be a problem that we might need to address at another point. Now, we can also create histograms and box plots of our residuals to do things like check for outliers. So if we do a histogram, we can specify the number of bins. And again, depending on how many observations you have, you may want to adjust that. We don't have a lot of observations, so we can't get too many bins for this example. And we can also do a box plot. Again, these are for one numerical variable at a time. And so that would be appropriate for just looking at the residuals. And again, our goal here is to see if they're normally distributed. And along with our normal probability plot, it does look like there is sort of a bit of a tail on this right side. And we can see there are some outliers out here, which isn't great. Our median is also a little bit to the left of center, which is another indication that maybe this data set is a little skewed. Certainly not entirely normal. Now, what we could do is we could try to remove the potentially problematic variables. So if we go back to our graph here, we might identify a couple of these as being potentially problematic. So what we can do is we can actually remove some observations from the data set. So for instance, if we wanted to extract just a couple of observations, we could, for instance, extract observation 18 and observation 20, if those were our problematic variables, our problematic observations. And then I created another data set, MT cars 2. so that I still have the original empty cars that I can refer back to if I need it, and then refit our linear model, MPG, QSEC, and this time I'll do with the 0 intercept. Empty cars 2, because that's we want to redo it without the bad values. I had a typo apparently. MPG, not MPQ. There we go. We can get our summary. And this is because we removed some potentially problematic values. We do have a higher R squared value than we had when we included those values. And we can also, again, calculate the predicted values and the residuals. Now, because these columns existed in our updated version of empty cars, the predicted column and the residual column already exist. So this will overwrite them with the new values. Actually, there we go. This is why I changed MT cars 2. This is why I changed the name of the data set, residuals and residuals fit 2. I have my 2's in every place. It looks like it. Fantastic. And then we can, again, plot our normal probability plot to see if we've gotten any improvements. And it does seem like this is a little bit less nasty. They are still a little bit off the ends, but it looks a little bit better. It doesn't look quite as terrible as our previous QQ plot with those other 2 values still included in the data set. Now, we do have other plots that we can extract from just plotting our model. And so I'm going to just go ahead and plot some of these alternatives that you can also inspect. So this was the QQ plot is the by default which equals 2. But if you plot which equals 1, then you get a plot of the residuals versus the fitted Y values. And again, this is not our traditional residual plot. We usually plot residuals versus the X values in the model, or sometimes the residuals versus the observed Y values. There are some analyses that you can do from this, but don't overinterpret this line that's being drawn on the graph here. Now, we also have some other ones that we can extract from this function from the fit summary. The third graph option is standardized residuals. So it's a scale location graph. The fourth option is a Cook's distance graph. Option 5 is residuals versus leverage, which is again a calculation that you can do that you can use to kind of try to interpret your residual values. And then 6 is again another Cook's distance versus leverage. And again, to understand how to interpret these, You would have to dig more into exactly what these graphs are telling you. But they are available inside this by just plotting your model summary. Now, if you just do plot and then the model name, then it's going to actually tell you hit return to see the next plot. And it is going to run through some of these graphs. So if I hit enter down here, it's going to plot my residuals versus fitted. It's going to plot my QQ plot. It's going to plot my scale location plot. It's going to plot my residuals versus leverage. So notice there are 6 possible graphs that you can get if you specify which equals 1, 2, 3, 4, 5, 6. But if you just plot the name of your model, then you'll get 4 of them plotted automatically just from that. So if you want to see them all, you would have to specify I believe these last 2 by hand.